The ratio of escape velocity at Earth is VE to the escape velocity at a planet is VP, whose radius and mean densities are twice as that of the Earth. That means Rp equal to 2 into Re and rho p equal to 2 into rho e. Now escape velocity formula is V equal to escape velocity on the Earth. So V equal to root over 2G, 2 into capital G. So escape velocity on the Earth formula is 2 into capital G capital M by R. If you are taking mass, that is nothing but normally density equal to mass per unit volume. Mass equal to volume into density. So this is the volume into density. So volume is nothing but 4 by 3 pi r cube rho. So that is mass. If you substitute in this case, we'll get 2g by r into 4 by 3 pi r cube rho. So now this will become r into root over 8 pi g by 3 into rho. That is nothing but density. So V by Vp, that is nothing but escape velocity on the earth by escape velocity of the planet. Then we can write Re by Rp equal to, so that is nothing but multiplication. Still it is density is there, right? We have to take the density relation also. Take the density relation itself. So into root over rho e by rho p. Then so we can take this condition. So write this condition. So you actually here radius of the planet. The radius of the planet is nothing but twice of the radius of the Earth. Radius of the density of the planet equal to twice of the density of the Earth. So if you write here V by Vp equal to Re by 2 Re into root over rho e by 2 into rho e. So everything will be get cancelled, then remaining value will be there. So 1 by 2 into root over 1 by 2. Root over 1 by 2. So that is nothing but 2 into root 2. That is nothing but V by Vp equal to, so 1 by 2 root 2. So that is the answer, 1 by 2 root 2. So which is the option? This is the answer. So if you like this content, do like, share and subscribe to Student the Brand. Thank you.